Well, hello there, YouTube. This is Ali from the AI Enthusiast, and we're going to be covering lecture 4 today in the QA series. And as discussed last time, we're going to be going over vector databases. And we're going to start off by talking about the motivation behind this. So we were talking about QA models and how you have to feed in the context, basically the background information, along with the question. Now, what happens if the context, the background information string, is so large? Well, in that scenario, we actually have to break it down. So over here on the left-hand side, if you have a large document or you have a lot of documents you're asking questions about, you're going to chunk them up. And then, for example, in chunks of 100 words, what you're going to do is you're going to convert them into embeddings. And these embeddings are going to essentially describe what's in the content of that chunk of text. And then from here, these embeddings, these are essentially vectors. So what will happen is when the user asks a question, you're going to convert the question into its own vector that represents, what that question is asking in terms of a mathematical notation, and then, a mathematical representation. And then this vector can be compared against all these vectors that you have in your database. And there you go. You take the nearest neighbor, the closest vector, and then that is the document that most likely contains the answer to the question that the user asked. And then from there, you pull in that document. And then what we were doing beforehand, where we provide the document, the background information, the question to the model, and then the model gives us the answer, that stays the same. And so this is, essentially the retriever side of it. It's retrieving you the right text. And then from there, that text is a small chunk, then you provide it to your QA model. So what are these vectors? They're essentially embeddings, right? So it's the same, very similar to basically a word embedding. So if you look at this word cat, we have a vector here. This is a 6 or 7-dimensional vector. And you can see it's a living being, that's a 0.6, feline's 0.9, and the list goes on. And this representation, we actually have machine learning models that'll actually train up to determine what these words should map to in terms of a vector. And likewise, you can then convert passages of text, like a paragraph or sentences, into vectors. So it's pretty much the exact same thing. We're converting these chunks of text into vectors. So now let's go into how we compare these vectors. So, you take your data, you take all your documents, you chunk them up, and then you put the chunks, you make them vectors. And then when the user asks a question, you want to know which chunk of text they're actually going to get that answer from, right? Which is the most relevant piece of text. The way you do that, you can actually use, you can compare vectors. One example is to use the distance formula, and this is in 3D. So this is taking the distance between two vectors in 3 dimensions. And as we know, this is 7 dimensions. You would just extend this formula to 7 dimensions. Another way to look at it is using the dot product formula. This is essentially like, if you've heard of cosine similarity, the idea is, if two vectors are similar, they're going to have a larger dot product. So there are other ways to determine how similar two vectors can be. This is just an example. So then, when you have these vectors of your text, what do you do with them? Well, you store them in your database. I already used that term before. And what I'm saying is I'm actually talking about vector databases. So these databases, their job is to store the text, and alongside it, each chunk of text, their vector. And so then these, similarity functions and essentially, this complexity is handled by the database. So how do we convert into a vector? We kind of skipped over that. I said it's a machine learning model, and that's exactly what it is. So this is the whole process. The first is step 1, ingestion. You have your large document or list of documents, you chunk it up, and then from here you use your embedding model, your embedding machine learning model that'll take the text and it'll convert it into a vector. So over here you can see this is one entry in the database. You have your text, it'll be a paragraph or a page of text, what have you, and then embedding, that's going to be some vector. Now that's your step 1, ingestion. From there, step 2, you have your answers, basically answering the question. So you provide the question, the user provides this question, and then the same embedding model is actually going to use this right here, is going to basically generate the vector. So this is the representation of the question. And then from there, we're going to do a comparison operation in the database. The database is then going to fetch and return, we're going to fetch, return, and we're going to get the closest chunk of text to this question that the user asked. And once you have now that context and you have the question, as you've seen in the previous lectures, you can then use the QA model and then get the answer. So now we have two ML models. We have the QA model, and then we have the embedding model. So this is the retrieving framework, and then you have the regular question answer framework. And yes, the vector database simplifies a lot of these operations. Let's go ahead and look into the code to see how all this plays out. So as always, go to the README and follow the README instructions. But I've already gotten into my environment. I'm just going to do Jupyter Notebook. Okay, so it's opening up. I'm going to go ahead and go to lecture 4. And then inside of here, once you pull this in, you just want to go to go to interactive.ipynb. And then from here, we're just going to get started. So first thing is first, imports. Then over here, guys, I have my documents. So I have 3 paragraphs, one on the United States, one on Russia, one in China. And then I just have like a key as well. So this is my document dictionary. And you can imagine you would actually pull this information out of PDFs, text files. So I'm just going to go ahead and run it. Step 2 and 3 is essentially split the text into pages, into chunks, and then make an embedding for each one. So we already have the chunks here in this example. So I use ChromaDB. So I'm importing ChromaDB, and I will create a collection. So this is literally how easy it is. In our tutorial, we're using ChromaDB. You are going to create a collection over here. Then from here, you're going to get that collection object. And then you can add in your documents into the database. Now, by default, internally, it's using an embedding model, all mini LM-L6-V2. So that's an actual ML model that's going to convert the text that we provided, each and every chunk, into a vector. So I do X for X in list. I'm going to get all the values, all the text strings here. That's going to be the document. And of course, you can also provide some sort of metadata just for your own, like for other uses. But essentially, I'm just saying source and I'm just saying book here. And then I'm just going to do that object for each one of the 3 documents we have here. And then everything has an ID. So I'm just going to convert the ID to a string. And there we go. We can add this to the collection. Now, you might have noticed at the bottom, it had like a loading screen. So I've already run this code. It's going to first have to fetch this model. It's going to have to download it. It takes a couple of seconds, maybe like a minute or so. But once it downloads the model, it's going to automatically convert these chunks of text into vectors. Now from here, the next step is we've already put it into our database. So going back to our presentation, we had essentially this over here. So we, at this point, have done step 1. We've basically put everything in our database. Next step is now to actually do the question answering. So going back, I have my question. What is the largest country by population and by land area? So in the text, Russia is the largest country in the world by land area. China is the most populous country in the world. USA, there's a bunch of facts about USA, but it's not the largest in either sense. So over here, I have my question. And this is where the vector database simplifies so much for us. We don't have to convert the question into a vector. Internally, the database will do that. And then we don't have to do any kind of similarity functions or any math. It'll already handle all of that for us. So you just provide the question, and I'm looking for 2 of the nearest chunks of text. You can just provide 1 here, and it'll get you the most similar piece of text, but I'm just providing 2. I'm going to go ahead and run that, and you can see the object below. So it'll give you the distance the question had to each of these documents, and then you can see the metadatas here, and then of course you can actually see the 2 documents, and surely enough we see Russia and then we see China here, and we don't see the USA document. It wasn't as similar. And then what you can do is you can I can print this out, so you can get the first document and then you can get the second document. So if I print this, I can see this is the second document, China, the most populous country in the world. So you can see this is what we had uploaded, and this is the second most popular query result that we get in relation to this question. So now that is essentially, we queried and we got the document. And now it's the exact same thing as what we did before. You have your document, the most relevant text, and then you have your question. And so lectures 2 and 3, we went over how you can use either Open Generative QA or Extractive QA to solve this problem and get an answer. So what I'm going to do here is also show you how you can use a different embedding model. So by default, it's using All Mini LM L6-V2. That's a good model. There's another one here that's I think slightly more performant, and there's some links you can visit. But the way you're going to do this, there's some utils, embedding functions you can basically import. You're going to have your model name, and this is like a pre-trained model, and then you have an embedding function. You create this, and this is essentially what it's doing is it's gonna tell ChromaDB how you want to generate the vector embeddings on each of the chunks of text that it gets and the question. So now you create a new collection, you specify the name of the collection, and then the embedding function here. So you can have your own embedding function. You can use something very simple. You can take bag of words, for example, or you could do TF-IDF. But you can do something more complex. So right now we're using embedding models, and that's really, how you want to do this if you want to get good results. And likewise, it's the same exact process. You're going to add in your sample text. Here it's typed text, and then IDs is 1. So I'm not going to run this, but it would just download this model, and then it'll run this code. So actually in the next video, I'm going to go over an example where I combine this retriever logic where I'm using the embedding and like the vector database to get the right document. I'll combine that with lectures 2 and 3 to actually do a full end-to-end question answering example on like Lord of the Rings text. So I'll be doing that. And then the following video, I really want to go into using like state-of-the-art models, using OpenAI's models, and you can see a huge performance increase. So stay tuned. If you like this video, please like and subscribe. I will talk to you next time. Thank you.